Alright, this is our second video on solving by factoring. Problem number 5. Got 4 sin x minus 1 equals 2 sin x plus 1. Um, Once again, this is not a problem where you have to do any factoring. You just have sort of these like terms. I have 4 sin x on the left and 2 sin x on the right. So I could subtract this 2 sin x to the left side. And if you take 4 sin x minus 2 sin x, you've got 2 sin x. Likewise, I could add this 1 to the other side, which gives me 2. Now if I divide both sides by 2, I get sin x equals 1. On the unit circle, there is only one place where sin x equals 1, and that happens to be up here at pi over 2 radians. So this problem has only one answer, and that is pi over 2. Alright, so we're going to go on to the second, or problem number 6 I should say. We got 3 tan squared x minus 1 equals 0. So even though there's a squared in it, this is probably not a factoring problem. We can solve this by just doing algebra undo operations that you should be used to. You would first add the 1 to the other side, and then divide both sides by 3. Next, we're going to have to take the square root of both sides, but remember, depending on how your algebra teacher taught this, either you're thinking of an absolute value type situation or whatever, but you should know that you get a plus or minus right here. So we have now just regular tan x is equal to plus or minus the square root of 1/3. Now, one useful way to think of this is just square root of 1 over square root of 3, which you should hopefully know means plus or minus 1 over the square root of 3, because the square root of 1 is just 1. And then, if you recall, the way we could rationalize this to get a value we might know a little better, multiply top and bottom by root 3. We end up with the tangent value we need, which is plus or minus root 3 over 3. So on the unit circle, the place where we get positive root 3 happens to be at pi over 6. The other place we get positive pi over 3, or positive root 3 over 3 for tangent, is down here at 7 pi over 6. These are the two positive value quadrants for tangent. Now, we also need negative root 3 over 3. So we're essentially just going to get this bow tie. And we're going to have these two angles here, which are 5 pi over 6 and 11 pi over 6. And those are our 4 answers. 1, 2, 3, 4. All right, let's go on to number 7. So we've got this equation that once again looks like a factoring problem. We've got negative 2 sin squared x plus 3 sin x minus 1 equals 0. So I don't like factoring problems with trinomials where the first leading coefficient is negative. So to make this problem easier, I'm going to multiply both sides of the equation by negative 1, which hopefully you know makes this problem into 2 sin squared x minus 3 sin x plus 1 equals 0. Another way to think of what I've done here is you could just add the 2 sin squared x to this side, subtract the 3 and sin x to both sides, and add 1 to both sides, and you'll end up with the exact same result. So now we're at the same situation we were earlier, where we have to factor a trinomial. And so when I break this into two binomials, the first part has to be 2 sin x times sin x to get to 2 sin squared x. And then I don't really have a lot of options here. I either can have two numbers plus 1 and plus 1 that multiply to 1, or negative 1 times negative 1 that multiplies to positive 1. Now a little bit of inside thinking here. I need the middle term to be negative, so that means I probably should use the negative numbers. If we want to double check it, I can look at the foiling. I get 2 sin squared x minus 2 sin x minus 3 sin x, and that does match the minus 3 sin x that I wanted. Now I can use the ZPP property, or zero product property, that was redundant, and I get 2 sin x minus 1 equals 0, and sin x minus 1 equals 0. So the first equation, if we solve that, we get 2 sin x equals 1, which means sin x equals a half. And in the second equation, we'll get sin x equals 1. So where does sine x equals a half? Well, that should happen when the y value is a half, which means that's the short side. So that happens at pi over 6. And there's another quadrant where that happens, and that happens to be at 5 pi over 6. For sine x to equal 1, there's only one place that happens. It's up here at pi over 2. So we have three answers. They are 5 pi over 6, pi over 6, and pi over 2. All right, one more problem for this video, number 8. And so we're supposed to solve 5 cosine x plus 1 equals 5. Lots of ways to do this algebraically. I like that I can just do this, divide both sides by 5, so that these 5's cancel. And now I'm just left with cosine x plus 1 equals 1. If I subtract the 1 to the other side, I now have cosine x equals 0. And now you have to think on the unit circle, when is the x value 0? And that should happen at two spots, at pi over 2 and at 3 pi over 2. And so, for this problem, those are our only two answers.